Hi, everyone. My name is Mark Chasseur. I'm the founder and publisher of R744.com, the world's leading marketplace for CO2 refrigeration, CO2 chillers, and CO2 heat pumps. And we've now started doing a series of live streams with some of the world's leading thought leaders in this space. And today I have the pleasure of interviewing Sergio Girotto from Italy, from the company, representing the company Enex, who is someone that is really well regarded globally within our industry as one of the leading entrepreneurs and researchers in this space. So I'd like to welcome you, Sergio.
Yeah. Thank you. Good morning or good afternoon to everybody.
Yeah, and there'll be some people also watching in Asia, so good evening to all of you as well. We'll be allowing for questions and answers after the session. So we've already got a question on the YouTube channel, but you can also submit comments on the LinkedIn page where we're streaming this video live, okay? And you can obviously watch it on r744.com. So Sergio, you've been working with CO2 for a long time, right? You started working in the 1990s, so close to 30 years ago with CO2. How did that happen? How did that come by?
It was exactly 1996.
Okay.
I was technical director of one large refrigeration company. In the last in the last 10 years, there were problems with GVP, with ODP of refrigerants. And there was a lot of confusion, continuously new refrigerant, new solutions. It was really a big mess in the beginning of the 90s, indirect systems and so on. When it happened that I had the chance to meet one person, Mr. Per Samuelsen from Norway. He was an entrepreneur. And he suggested me to meet, he understood my interest in natural refrigerants, and he proposed me to meet Sintef.
Okay.
I went to Trondheim with him, and I met Jostein Pettersen and Peter Nexo.
Mm-hmm.
They explained me the situation with CO2, and it was a light that switching on. I understood that the problem was not a fundamental problem, it was a technical economic problem, in the sense that it was possible to do with CO2, for example. It was already possible to do with ammonia, but we were dealing with small systems of 100 kilowatt. For those one, ammonia is not too expensive.
Mm-hmm.
And I understood that the problem was economic. In practice, the solution did exist, a semi-hermetic compressor, but nobody did yet that in the industry. I remember that when we returned to the airport, Samuelsen called Mario Dorin and said, "Mario, why don't you produce a compressor for us?"
Okay.
And a few days after, I contacted Mario Dorin from the Dorin company, and they really started from nothing, a semi-hermetic CO2 compressor.
Wow.
And 1 year later, the compressor was ready, the prototype was ready.
Yeah.
And there started the adventure of CO2. It was 97.
Okay, so that partnership with Dorin at the beginning was key.
Yeah.
Okay, so so 25, 26 years now that you've been working concretely with CO2. You made a name for yourself, right? Before creating your own company, Enex, that we'll learn about in a minute. You were also involved in, you led the project for the first large CO2 supermarket, right? This is 20 odd years ago.
Yes, I led the development of CO2. We installed the first 2 or 3 real supermarkets. Then other came in the 2002, 2003 with my previous company. I can say Costan. This is
okay.
It's correct to say what was the company.
Sure.
After that, it was 20 years I was doing the it was in the same company. It was 20 years. It's a lot of time. I need to do something else.
Okay.
And also, CO2 was really a niche for them.
Yeah.
It was nothing. It was zero.
Yeah, there was nothing. There was nothing.
I decided to make something on my own to speed up in another sector, in the heat pump sector, okay, as a consultant. So I founded my company, and in the first year I traveled a lot. I met a lot of people for proposing to develop heat pumps with CO2 and so on.
Okay.
But,
so this is the same time that the CO2 heat pumps were taking off in Japan. So I guess you spent a bit of time in Japan as well, the acute heat pumps, yeah?
Exactly, it was that time.
Yeah.
Suddenly, I understood, little by little, or one day, I understood that the people I contacted didn't want the consultancy. They wanted the product. and they didn't want yet the CO2 heat pumps because for a simple reason I didn't realize, for the reason that they were too different from conventional heat pumps. Okay. Conventional heat pumps can work with any delta T, with CO2 heat pumps are more difficult to implement. They wanted a one-to-one product to change the existing heat pumps, but it was not possible with CO2. It was not possible at those conditions. We could have started selling water reservoir, but it was too complicated. So I had a request to return to design a refrigeration system, as I did before. So before with my previous company, we did probably 20, 30 installations.
Stores. And these were transcritical stores, right?
Yes.
Yeah.
It was Switzerland. My old friend, Kurt Goetz, asked me to make a product for them. He introduced me to Frigo Consulting. I already knew Frigo Consulting, but they found a customer interested, and we started with the first real installation in Switzerland. Was close to Bern in 2006.
I remember writing about this store on r74.com because that's about the time when we started to exist as the website r74.com. So no, this was a big deal. This was a big deal back in those days. And I know, so Frigo Consulting were a key partner in this for you, right? Try and get into the Swiss market that was a leader in this space at the very beginning, together with the Scandinavians. Yes. Yeah. So, all right. So you created Enex in 2004. You started working with refrigeration very early on, and you'd already had that experience with Costan. So, creating a company solely on CO2, back in those days, you'd have thought that was absolute. Either you were crazy or you were a genius. I mean, most people in those days would say CO2 will never work. It's not efficient, especially not in high ambient temperatures. It only works in the north of Norway, blah, 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 blah. The usual arguments that have been used. It's high pressure, it's expensive, et cetera, et cetera, et cetera. So how did you deal with all those challenges, and how did you prove that you could actually make a viable business out of CO2?
It is true what you say. I remember when I went to Cilvento, or when I went to Mostra Convegno in Milano, I met some people, and the reaction was the same. Ha, you are the one. We have good luck. Yeah. This lasted until 2011, 2012. But before, I simply decided to follow the people interested. Enex was a small company. Yeah. Probably at that time, in 2008 to 2010, we were 10 people in total. So we did not need big production with, 2 million turnover. We reached the break even. Yeah. And so I followed, there were people interested in CO2, and I made CO2, and we developed a lot of new things. Situation changed completely in 2012, 2013. In 2010, a new shareholder entered Enex, Urre, a Finnish company, Urre. And with them, I gained the part of the Swedish and the Finnish market.
Okay.
And suddenly there was a jump in our turnover. We had Switzerland, we had Sweden, which was a good market, and Finland. And then some years later came Romania and so on. But suddenly in 2000, I developed some new things like liquid ejector was developed by us. Parallel compression was developed by us.
So we'll talk about the components later, because I do have a question about the liquid. You've got a patent for the liquid ejector for overfeeding evaporators, right? That's you. So I want to ask about that, but not right now. It's like, because you're going into because you're a brilliant engineer, so you're going to go straight into the technical stuff. I'm still in the big picture stuff right now. So, but the business. So you started to grow in the early 2010. You brought on a new shareholder, and then you were growing as a business, and you could see that some of your competitors, like Advancer, like Green and Cool, they were starting to get purchased. They were bought by bigger companies, right?
Yeah.
So then you were still one of the small guys until just a few years ago. And then what happened there? You basically got acquired, right, by a new entity called Cold Chain Capital. Tell us about that, please.
We reached 10 million turnover in 2019.
Okay.
And I had already before several requests. Somebody wanted to enter in the company, but I went deep in some of them, but I was not convinced.
Okay.
In end of 2019, in October, November, I met Greg Del Dick. He came here and he made me a proposal. He said, "Do you want to grow?"
So who is Greg Del Dick?
Greg Del Dick is the general manager, the founder of CCC Holding.
Okay, but he's got a background in Carrier, right? He made his career in Carrier.
I discovered later. He was a former general manager or CEO of Carrier Refrigeration.
That's a big deal, right? So he had knowledge of the market already. So he knew what he was doing when he was approaching you. Right?
When I met him, he was simply a man with a tie.
Okay.
I don't know the history. He made me a gift. Give me a gift of the story of Willis Carrier.
Okay.
I have in my room, close to my bed. So sometimes I read. I have already read, but I repeat some things and I recognize some situations. And he proposed me to grow. Do you want to grow? We can make a partnership. We enter in a company, or you have this advantage. I decided after a couple of weeks, I thought deeply, and I decided, yes, why not? And 2 months later, we made the agreement, the deal, even because there were not problems in the company. So the due diligence was very easy, simple. Smooth, I would say, because there were no strange situation. I was the only shareholder. My wife, which is very precise, controlled administration. So it was really a smooth procedure.
Okay, so you then became part of the CCC group of family companies, right? Which is continuously growing. I need to do an interview with Greg about that in the future. If you're watching this, please, just a reminder to you about how you want to grow this company European-wide. But on the Enex specifically, you've completely changed now, right? In those last 2 years, there's been obviously COVID, but despite that, you have had rocket growth.
Yes.
And you've built out your capacity, your team, your resources. You've changed completely in the marketplace. Would that be a fair assumption?
Yes, it's correct. We changed completely. Now, Enex, I am still working in an important role in Enex, but there are several exceptional people working with me and doing what I did before. Also because I would like to return to technique, to research and development, I hope from next year. So I don't want to take care of
the business side.
The business side, which I like, but I am more a technician than a
you want to play with your toys.
Yeah, yes.
Now, about the toys, you had a reputation in the market of Enex being the Ferrari in the market. Is that still fair to say that you're the Ferrari in the industry, or has the Enex changed a little bit? By Ferrari, the assumption was, yes, great quality, great performance, but also high price.
No, I would say.
How has that changed?
I would say the products are the same as before. We introduced some new products, but the products are exactly the same as before. We optimized something in the products, but I don't see a big difference between now and before. What is changed is the volume. The volume, when you double or triple the turnover, you need more people. So we have a lot of new people. We were before, when I sold, just to use this word, 50 people. Now we are more than 100. So, you hire, somebody is good, somebody is not. They take some months. So there is a little bit of
growing pains.
Growth pains, yes.
Yeah. But like, are you able to say what your turnover is now or the last year? Is that public information? Is that something you're willing to share of the growth?
Last year was about more than 18 millions. It was doubled compared to the year before. The year before, 2020, we had a drop due to COVID situation.
Okay, but then you caught that gap, right? You were able to catch that in 20.
It was doubled compared to 2020. And this year we are, obviously we are not close the year, but the tendency is to grow another 30%. And we are on the track. Okay,
so you're at full capacity right now.
We are at full capacity, and this is the next, when you grow, it's like reducing the level of water in the sea. The rocks emerge as soon as you reduce the level. Now, the next the next obstacle is the capacity. And this is a step I could not do on my
yourself.
own.
So that's where the partnership with CCC helps you do that financially, right?
We had a new building which is owned, and the new building will be used for production starting from 1st of July. Little by little, but 1st of July. And by the end of this year, we'll move all the production or big part of the production there. Some products will still be manufactured here, but most of the products.
Where is here? Because for those, I know where you are, but for the ones watching that don't know where Enex is, where in Italy are you?
We are in Treviso, about not exactly in the town of Treviso, but 5 kilometers north of Treviso, which is 35 kilometers from Venice.
Okay, so everyone knows where Venice is, but they don't know where Treviso is, but it's close to Venice. So in the northeastern part of Italy. Okay.
There is an airport, served by Ryanair, so it's very, very easy to arrive.
So you're doubling your capacity. You're moving into a whole new facility this summer. You're also going to be able to, I understand you're going to have a full-time, like a proper test lab now, right?
Yes.
A test facility where you're going to be able to test new products in new situations, new applications. So tell us a little bit about that, because that's, I guess, for you as an engineer, that must be super exciting, right?
Yes. So far, one of the problems was the space available. We dedicated some space in 1 year ago to a new lab, 1.5 years ago for a laboratory. And we tested very well several things like heat pumps and chillers. Now we have this laboratory includes two engineers working full time on that, and we are really testing very, very well heat pumps and chillers.
This is a big deal. This is huge.
Products which really need. I would say the perfection before we enter the market. The refrigeration systems goes in the hands of a refrigeration engineer. So they can repair, they can adapt something. But normally chillers and heat pumps goes in the hands of plumbers, or a little bit of plumbers, a little more than plumbers. Good plumbers, nothing to do, is a very honest business,
trade.
But the specialty is dealing with water, not dealing with refrigerant. So the part with the refrigerant must be perfect. They should never. So this is why it is particularly important that a product like a heat pump and a chiller are really tested well, and much more than refrigeration units. Different solutions.
So about we're going to talk about refrigeration, chillers, and heat pumps in a second. One last question I have about the general situation. So, how many CO2 refrigeration systems, and you can include chillers and heat pumps, how many CO2 products have you sold so far since you created Enex? What are we talking about? Is it 500, 5,000?
No,
how many is it?
Until 2019, the last year, I was alone, almost less than 2,000.
Okay, less than 2,000.
Yeah, because it was 150 per year, 10 years, 10, 12 years. Now, even 170 per year, but only some years, not always.
Okay.
Last year and this year, we produced about 1,000 units. So we are about 3,000. 1,000.
So wait. So you were on 150 a year, and now in the last 2 years, you've averaged 500.
For 400, this year will be more than 500. Yes.
And this is before you move into this facility that will allow you to even increase. So you are completely changing scale now.
Yes.
Yeah. So you'll be making 1,000 of these a year, right? That should be relatively soon, right?
This is the final budget. The budget in 3 years is double than the one we'll do today. So it will be 1,000 per year. This will be the number.
Okay. Now, so Europe for refrigeration has been leading. We have over 40,000 CO2 stores in Europe today, right? You were there right at the beginning. You were the first, right, in 2001. So you've seen that journey. But potentially, is your opinion that basically all the supermarkets, the vast majority of supermarkets in Europe could go to CO2 and possibly hydrocarbons? Is that the way you see it changing, and it's just a matter of time?
Yeah, it's a matter of time. The cost reduction, the more scale optimization, but tendentially I see CO2 and propane as the preferred,
as the leaders.
CO2 in the direct expansion system, propane in the chiller, in the small chillers.
So you see Europe continuing to go in the direction of natural refrigerants, and in your case, CO2, right? For supermarkets, that's a great market to grow, and we're only really at the beginning of this transition. This decade will basically be the decade of natural refrigerants, right, in Europe, and that will only become even more clear with the new F-gas regulation next year. But what about outside Europe? Where have you? I know that I remember meeting you in Australia once, where you were doing some projects there. You've done stuff in Jordan. You've been all over the place, right? But where have you decided to have you actually thought about having Enex present in other regions of the world and properly present, not just one or two experiments, but actually building a business in different regions? Is there a focus there at all?
We built up in the past a business in Brazil, in South America, Brazil, Ecuador, Colombia. Of course, it is at the beginning, but you really see the interest in CO2 in those countries. Not for all the application. The small supermarkets are with propane indirect, but Colombia, for example, is very interested in CO2. They want the best of the technology of Europe. They like things produced in Italy, in Germany, in France, but in this case, Italy and Germany will produce more systems. So they are in love with this situation. They like it. So South America certainly is the one king newcomer in the refrigeration. Of course, North America. I had some proposal in the past to enter North America.
Why did you not do it? Why did you never go to North America?
Alone, it was very difficult. I know America because I worked with Costan. We went to America sometimes, so I know how difficult it is. The distances are enormous. It's not like in Italy, you know, you create a supermarket 100 kilometers, it seems far away. In America, far away means 3,000 kilometers. You have the problem of service. So I decided not to do that, even if I had a serious request.
Okay.
Very serious. We'll see in future. Could be interesting, but you need a factory there. You know, it's not
you need to assemble in the US and make it there. Yeah, that's what a lot of other of your competitors are doing. So, not that many actually, but they're obviously American manufacturers already have that. And we'll be talking about that actually at Atmosphere America next week in DC. But okay, so you've never really thought about North America. You've never decided. So Europe, and Latin America, the two pockets of growth that you see, and you see already with Europe alone, you're going to scale up. You know, in the space of a few years, you've gone from 150 to 1,000 a year. That's just for refrigeration. So on the refrigeration side, you started with the standard CO2 systems, and then you were involved. So you were involved in the development of CO2 systems to parallel compression and so forth, and boosters. You patented the ejector. You have your own ejector solution, right? Yes. So tell us a little bit about that. Why is that important for the non-technical minded people?
The ejector solution is important because it allows a very simple control of injection of refrigerant in the evaporators, and allows overfeeding evaporators with very high efficiency in a simple way and safe way, as the ejector pumps back the liquid which exit the evaporators into the receiver again. In few words, it is like a pumped system without a pump, because the pump is a static device, which is the ejector. Okay.
So why did you do your own ejector? Why didn't you go and work with some suppliers that had solutions coming out there? What was the rationale for that?
No. At the beginning, there were no ejectors in the market. In 2012, when I developed this solution, I was working with Sintef for testing their ejector in a heat pump.
Okay.
But it didn't work. But I discovered that it was pumping liquid. So it came in my mind this idea of pumping liquid back to receiver in the CO2 system. Okay. At the beginning, there were no ejector on the market.
Yeah.
So we produced our own ejector. For the 2-3 years, we continued to produce. Then, but the ejector made by us or made by another one is a piece of metal. Is nothing.
Yeah.
Then it came Danfoss, which produced their own ejector, Karel, Wurm, and probably others. So we decided to use their ejector. We are We are using now our solution, but is a solution they use also Danfoss and they have made some small modification but it's basically very similar. But we are using the standard components now.
Okay.
You know, at a certain point, it became a gap. Because I want to buy your ejector because Danfoss produce ejector. No, we are using also Danfoss ejector. We are promoting the idea, the technical solution, not the piece of metal.
So you've seen the CO2 racks evolve over time in refrigeration. You've also, how involved are you in CO2 refrigeration for industrial applications? Is that an area of focus for Enex?
Yes, we are especially dedicated now to industrial refrigeration. If you come now in our factory, probably there will be, in total, in this moment, there are 40 units,
Okay.
Of which 30 are industrial and
Wow.
10 are commercial. So we are more focused on industrial than of course, there is industrial with 300 kilowatt, but there is also industrial with 1000 kilowatt or 900 kilowatt.
So what's the biggest megawatt you've done?
We reached almost a megawatt.
Almost a megawatt. So you haven't gone into the multiple megawatts like some of your competitors yet?
No, in reality, nobody did more than 1 megawatt because there are a problem of compressor.
But they've put more racks. So on the project side, what's the biggest project you've done?
Probably around 3 megawatt.
3 megawatts. Okay.
Three units.
Okay. And on the compressor side, so I guess you work with Dorin. You've been working with them for 20 odd years. They were there at the very beginning in your CO2 journey. But if you're trying to scale up your business, is that forcing you also to work with some of their competitors?
Yes.
Like Bach and like Bitzer and others. I mean, is that something that you're having to do? You're having to work with multiple different suppliers and you're working with them to build bigger compressors because you see that as absolute necessity to capture new market?
We are, at the beginning, we worked only with Bitzer because for some reasons, first of all, because there were very few compressors on the market in 2010. Mm-hmm. Then we started to work with Bitzer, and we had Dorin and Bitzer. Bitzer grow more and more. Now probably they are 60% and 40%, something like that. We like both of them. We decide which one to use depending on the situation. Sometimes Dorin has larger compressor, arrive at the moment up to 60 cubic meter per hour. Soon they will have 100 cubic meter per hour. Bitzer is very close, but not yet there. They will be, I think, in some months they will be there. But we use both of them. We have used also other brands like Girotto, very few, because in the end the compressor is
it's the heart
of the system, and the customer pretends to select which one he wants.
Okay. So you see industrial only growing? Yes. And does that mean that you're so how does that change your business and focus? Because these are bigger projects. They're worth a lot more money, but they're more tailored, right? They're not standardized. Or are you trying to standardize these racks also for the bigger systems, for the bigger installs? Is that the approach, or is it because you can have a much more tailored approach, which is something that you probably enjoy more as an engineer?
No, if you do 2 systems per year, it's easy to make tailor-made machines.
Sure.
But if you make 100 big machines, it is better to follow a standard, almost a standard. We adapt. We have more or less a standard design, proven, reliable, and so on. But we try to standardize at least the basic diagram, the basic design.
So then, out of those 1,000 stores that you want to, 1,000 units you want to be selling a year very soon for refrigeration, how much of that will be for industrial?
If we look at the percentage of today, probably will be 50 or 60%.
What? Half of the CO2 business will be in industrial? Wow. That's a surprise to me. That's a surprise to me.
There are many, really many. You know, the retail refrigeration we follow. We have a good customer, but there are several competitors, and the competition is very tough. And we want to have a more wide approach to the market, and we are good. We consider ourselves good in special machines. We face the industrial market, which is very, very promising.
Okay. And industrial market, can you be specific what you mean by that? Which type of applications? So which type of target groups are you looking for? Which kind of customers are you looking for?
There are chillers for dairy, chillers for machines for wineries,
okay,
skating rinks, marine refrigeration.
Okay. So there's a whole variety of different end uses.
Yes, it's incredible how many there are. I didn't know before.
That's good for you, right? Because now that you've got more resources and you've got a bigger team, you can target more markets. So that's only a good thing, I would say, right? So you're trying to move your business away from retail, being more dependent on retail and diversifying the different sources, right? Is that deliberate?
We are not moving away. We are doing both. Now
yeah,
we
you're
have
trying
the resources to do.
Yeah.
But retail requires more standardization, requires more preparation. You have few customers with big volumes. Retail, you have less customer, but many more.
Yep.
No, sorry, I said wrong. You have customers buying once per year, not 20 units per year or 30 units per year.
Yeah.
So you need to follow each project very carefully. It's a different approach, but now we have the resources to do.
Okay, so this is all CO2. You've never done hydrocarbons or ammonia or water or air. Why?
At the beginning of Enex, we made propane. We made some installation with propane. They worked very well, very, very well. It was for apple conservation, apple in Switzerland. But soonest what happened was that some suppliers came here. They said, you are doing propane, so you don't believe anymore on CO2. So I discovered a marketing approach that should be followed, that you need a clear focus on what you do. You cannot do too many things. You have to do one thing. The market is big enough anyway. We don't know to do. Simply at that time, the turnover was 500,000 euros. So 100,000 was
a big deal.
20% more. But once your market is better to follow there, you specialize on that. The customer can use propane, can use ammonia. It comes with you when he wants really CO2.
Okay.
This is the lesson I learned.
So what about, refrigeration, it's fair to say in Europe and other markets will follow, we believe, that, they're going to natural refrigerants, right? What about buildings? What about air conditioning for people in big buildings that are everywhere, and they're the biggest market share of all refrigerants, and they have the biggest impact on the environment by far? What have you done in there? Do you think CO2 could enter this market? Not process cooling for industrial applications, right? Which is the kind of the beginning. I'm talking about buildings and cooling people. Is that something that you think could be done?
Yeah, we have already done in 2000.
On a scale, you've done a few of these with your Yukon series, but how are you? Could this be the biggest product range you have in the future? Is this where you see the future, or is it going to be just a niche thing?
No. I think it can be the future. We need to industrialize the products because the price gap between an HFO chiller or a 410A chiller and a CO2 chiller is too important when the mechanism of buying is not the end user selecting. When is the contractor, the main contractor doing building, and we try to squeeze everybody. So there the difficulty, if the law, until the law will allow to use HFO or 410, certainly we need to stay on niche. But as soon as the people and the legislators will gain acknowledgement that also HFO and 410A are a threat to the ambient, probably something will happen.
Okay, so by that you're saying that you're based in Europe. You're reading regular reports about HFOs and their degradation products that are basically polluting our water, to simplify. All right. So one thing was polluting the atmosphere. Now it's about polluting the water. So we know that this is a problem for HFOs, and more people are starting to realize that, especially end users and governments. So what you're saying is that as more and more people get aware of that, then you hope that then that will kind of incentivize more people to then go to a natural refrigerant HVAC solutions, and not just look at the price, the capital cost up front, but also look at other reasons, other aspects. Yeah, is that your thinking?
Yes.
Okay.
As in the beginning of my adventure with refrigeration, there were companies producing wine or producing yogurt that had organized a tour in the factory, and they wanted to show to their customers, the end user, how green they were. So they bought chillers or a machine with CO2 just to show the green focus of their ambient. And also now there are companies buying chillers with CO2 for air conditioning.
Yeah. Yes.
Unfortunately, they are very little. They're very few. But in future, I hope if legislation changes a little bit, it is more difficult because the market of chillers is much bigger than the market of refrigeration.
Oh yeah, so it's 10 times bigger, much bigger.
It won't be easy, but
but that's the new market opportunity for natural refrigerants, right? Yes. And that will be exciting, because a lot of the ideas, the brilliant ideas you've had over your career so far, you'll be thinking, well, I can apply that knowledge to chillers, and I can apply that to commercial HVAC solutions. It's not going to be like, you're not starting from zero. You're starting with already 20 years of top experience. So the transition will be a lot easier.
Yeah.
And if the price is only an issue, then, there'll be competitors coming in the market. There will be other manufacturers that will have these solutions too. And then, when people are aware of the other environmental issues with HFOs, then, this pressure is only going to get worse. It's only going to get worse. All right. So, okay. But what about heat pumps? You actually started with heat pumps, right? So now this year with the war in Ukraine, everyone's talking about heat pumps. So what's been your journey with CO2 heat pumps?
I started the first heat pump in 2010, 12 years ago. And we still produce that machine. We modified, improved, but we still have the family of 8, which is a product, a heat pump for hot water, high temperature hot water, similar to those produced in Japan.
So it's like an EcoCute. And they're sourced, Okay.
We have the widest range in the market. We have 5 or 6 models from 10 kilowatt up to 100 kilowatt. We are selling quite a lot.
Okay.
And but it is a particular application of heat pumps. Heat pumps for space heating. It's a different product. We have one range. At the moment, it comes from Yukon range. Yukon has 3 deployment. One is only chiller. One is a chiller reversible heat pump, and the third one is only heat pump. We have 3. We have that product. We have a request. We are doing, but not many yet. But there will be a next market.
So you can see heat pumps coming for space heating as well. You can see that being a market growth opportunity for you.
Yes, for CO2, I would say the large capacities. For small plants, I guess the propane heat pumps are more favorable for the price.
So your perspective on the industry, because you've been working in this space for a long time. In Brussels, where a lot of the stakeholders are trying to influence policy on F-gas and on heat pumps, the general message from the, let's just say the conservative part of the industry are saying, natural refrigerant heat pumps, whether that's propane, CO2, ammonia, or water. Now, doesn't work. There's not enough scale. It won't be enough to meet the demands that we have for heat pumps in the future. Do you agree?
No, I don't agree. It's probably today we are not the capacity to do that, to cover. It's a huge market, a million of pieces. Probably today there are not, there are only two, as far as I know, hermetic compressors, Panasonic and Toshiba. There are few plate heat exchangers. So it's not easy to grow at the level on numbers, but I think we can do really everything.
Okay. And so you think 5 years from now, 3 to 5 years from now, the situation could be very different?
Probably more, but 5 years will be enough to change something.
Yeah. Okay. So, all right. So I'm just looking at the time. We're coming close to the end of the interview. I did want to ask you about, before we open up to questions, artificial intelligence. I read an article about you in preparation for this interview, and you talked about how artificial intelligence could become could be another revolution within the cooling industry. So what did you mean by that? How do you see that being applied to what you're doing in Enex? How does that change the way you operate and support your customers?
It is still a research argument. It's not in the field, but there are at least two use of artificial intelligence. One is to understand how the system works.
So the collection and analysis of the data, the constant data, yeah? Okay.
Analysis of predictive analysis, understand when the charge refrigerant is not sufficient, when the compressor is degrading, when the efficiency, and we are already doing something like that, but certainly this is a direction of development. Mm-hmm. Another one is to the controls. The controls can be improved very much using artificial intelligence. For example, I have just seen an example a couple of months ago when I spoke about that with a potential supplier. They have developed one system for optimizing the temperature of the water for a heat pump, collecting data from one heating season. The system understands what is the maximum level so as to maximize efficiency. Wow. There are things of this type which can be done.
So then you can only see improvements in performance then of the systems, yes, right?
Yes.
Yeah. Okay.
And more reliability. And more reliability.
Okay, yeah, because you'll be putting less stress on some key components, right? So that they can last longer as well.
Yeah.
Yeah. Okay. All right. So question time. I'm just checking with my colleagues who are in the background, seeing if we've got any questions. I see that we got one question on YouTube. Yay. We got someone watching on YouTube. So the question from YouTube is, okay, I got to read this out. Possible CO2 systems for only heating mode for cold regions like Canada, when they have a minus 25 degrees Celsius air and we need 80 to 90 Celsius hot water. Is this possible?
No, I think it's not possible with any refrigerant. You can do something using cascade, multiple cascade, but with a simple system, this is not possible. This has the limitation is not the CO2 itself or the propane itself. The limitation is the second law of thermodynamics or the Carnot theorem. It's nothing to do against that. To have a very high delta T, the consequence is that you reduce the efficiency. So okay. If you get a COP of say 3.5 from 0 degrees of ambient to 40 degrees inside the temperature in the ambient. In this case, you will have a COP of 1.5, which is not convenient
Enough.
if you consider the cost.
Okay, so you see that that's not actually possible from a cost point of view and a performance point of view.
I think the problem is the cost, yes.
Okay, so and that's applicable to any refrigerant, right? It's not just a challenge of CO2.
It is the same for everything.
Building on that, have you looked at ultra high temp CO2 heat pumps beyond 100 Celsius? Is that something that you've looked at as a possibility? Because, you know, in other parts of Europe, they are investigating that seriously to see if CO2 can go beyond 100 degrees Celsius. Is that something that you thought about?
No, first of all, this is a research field I don't follow because since the last 10 years, I have not gone with the two innovative things because we are ready to do. But I know that there are systems more promising. Okay. I don't know. Probably 100 degrees, yes. There are systems more promising with hydrocarbons. I think with R600, yes.
Oh, with R600. Okay.
I have read something from my friends of laboratory, of scientists, scientist friends.
Okay. So it's not the CO2, it'd be more a hydrocarbon that would be used in this case.
I'm not aware, we are not doing that.
Okay. That's all right. So do we have any questions from anyone on LinkedIn? Okay, so no other questions at the moment. All right, well, Sergio, I want to thank you for taking the time today to talk with us at r74.com. It's been a pleasure. I'm just looking now to see if if I missed any possible questions that I had for you in preparation for this interview. No, I think we've covered everything. I think we've talked about different applications of CO2, your history, your journey of Enex, where you see the future. And I guess to finish off, I mean, you must be quite happy with the way things have turned out for you after 20 years, right?
Yes, I'm quite satisfied. Sometimes I think what I would have done if I was not taking the risk 20 years ago.
Yeah. Do you think you would have been on the other side saying, CO2 cannot work?
No.
No, never? That would never have been you?
No, probably I would have many hobbies like mushrooms.
Yeah, okay. So thank God that you ended up going in CO2 because you made a huge impact. You got our Person of the Year award for Accelerate Europe back in 2018. So again, congratulations on that. And I think a lot of people in the industry respected that award, right? They said that you deserved it. Even your competitors said that. So that's a great achievement. So you've got the respect of your competitors and peers, and that's always a good thing. So Sergio, thank you again. Grazie. And then we will be in touch, and we'll be sharing this recording on the internet going forward. So have a great day. Bye everyone for watching. Thank you, Sergio.